Hi. Hello, viewers. All right, we have a question here. If the rate of diffusion of oxygen gas is 1, what will be the rate of diffusion of methane under the same condition? So we are asked to calculate the rate of diffusion of methane if we have calculated the rate of diffusion of oxygen and it's 1. So quickly, what is diffusion? Diffusion is the movement of gases from the point of higher concentration to the rate of lower concentration. So how do we calculate that? This brings us back to gas laws, where we talk about Graham's law of diffusion. And Graham's law of diffusion gave us a formula for diffusion. And the formula goes this way: R1 all over R2 is equal to the square root of M2 all over M1. Now, what does all this parameter means? The R1 is the rate of diffusion of the first gas. The R2 is the rate of diffusion of the second gas. The M2 is the molar mass, or the mass or the weight of the second gas, and the M1 is the weight of the first gas. Now let's define these parameters. We are told that the rate of the first gas, which is the oxygen gas that was mentioned to us, is 1. Now our R2, the rate of methane, which we don't know, question mark, that is what we are asked to find. Now our M1, the molar mass of oxygen, we know that the molar mass of oxygen atom, one oxygen atom, is 16. Now what is the molar mass of oxygen atom O2? So we know that oxygen gas comes in pair. It's a diatomic gas, it comes in pair. So we multiply 16 by 2 and it is 32. So what is now the molar mass of our methane gas? Methane gas, the formula is CH4. We know that carbon is 12 times plus hydrogen, which is 1 times 4, and this will give us 16. So we know that our M2 is 16. So if our M2 is 16, we have to plug all these parameters in our equation. What will our equation look like? So our R1, instead of R1, we have to write 1. R2, question mark, which we are asked to find, the square root of M2, which is 16, divided by M1, which is the oxygen gas, 32. Now, the next is to solve, we have to solve this using our mathematical knowledge, right? So first, we take the square root of 16 and 32. The square root of 16 and 32, 16 gives us 4, and 32 gives us a decimal, which is 5.57. Because multiply both sides, and R2 will give us 5.57 divided by 4. So our final answer will be R2 equal to 1.4. So in summary, if the rate of oxygen gas, which its molar mass is 32, under the same condition, the rate of methane gas, CH4, will be 1.4. Bye for now.